Hello everyone. This is part 5 of the lecture series of numerical matrix methods for solving the system of linear algebraic equations. So again, for simplicity, we are going to consider the system of three equations in three unknowns. But unlike the other methods, in this method we are not going to rewrite the system in the matrix form, but instead what I'm going to do is I'm going to use each of these equations to write x, y, z. So what I'm going to do, I'm going to use this first equation to write x. That means I will be taking this b1y and c1z to RHS, and then I'm going to write this particular equation number 1 for x. I'm going to use this equation 2 for y to write y, and then I'm going to use this equation 3 to write z. So when I do that, so I'm going to use a kind of algorithm. So what is the step 1? Step 1, we write x1, x2, x3. Here x1, x2, x3 are nothing but x, y and z. So I'm going to write x as this. So if you can see, this equation is rewritten as the equation of x. In a similar way, you can write y as well as z. So I want you to pause the video now and please check how this x, y and z have been formed. So unlike the other methods, Gauss Seidel method is an iterative method. So if you look at this equation, how do we iterate? We need to have some initial values of x, y, z, x, y and z, and then we start substituting those values in those equations, in these equations, and then we get the new value of x, y, z. So how do we do that? That is, let us see step 2. So step 2, what we do is we perform the first iteration by taking the initial values of x, y, z as I'm going to denote x now as x0. So this is the first iteration, that is the 0th value. So I'm going to write x0 equal to 0, I'm going to take y0 equal to 0 and z0 equal to 0. So when I do that, I'm going to get the new values of x, y, z. Since I denoted the first values of x, y, z as x0, y0, z0, my new values I'm going to denote by x1, y1 and z1. So if you look at this RHS, x1 is given by 1 upon a1 into bracket d1 minus b1 times y0 minus c1 times z0. Since at the time of calculation of x1, the values of y and z that we know are nothing but these values, and therefore I'm going to use these values here. Now let us go to the next calculation of y1. So you can see y1. If you want, you can pause the video and see what is the equation of y1 from the previous slide. So y1 was 1 upon b2 times bracket d2 minus a2 times now x1. So here I'm not using x0, but I'm using x1. Why? Because x1 was already calculated in the previous step. So therefore I'm using x1 minus c2 times z0. But I'm still using z0 because I do not have the new value of z. So I have to use the value of z which is known to me, and that is z0. Okay, so in this way we calculate y1. Let us see how do we calculate z1. So when we calculate the new value of z, that is when we go from z0 to z1, what we get is 1 upon c3 times bracket d3 minus a3 times x1. Why x1? Because we have already calculated the new value of x, that is x1. So we always use the new value of x, that is x1, minus b times now y1. So here I am not using y0 now because I have already calculated the new value of y, that is y1, and therefore I am using the new value of y, that is y1. So that is step 2. So in the step 2, what we get is we get the new value of x as x1, y1, z1. So what we have to do is we have to keep on calculating these values. We have to keep on iterating this. So let us see what we will get in next step. So in the next step, we perform second iteration by taking the initial values as x equal to x1, y equal to y1 and z equal to z1. So if you recall, just 2 minutes ago I told you that the first iteration was performed using the values of x, y, z as x0, y0, z0. So here for the second iteration, the initial values are going to be x1, y1 and z1. So when we do that, I'm going to get now new values of x, y, z as x2, y2 and z2. Please pause the video and check these equations, and I hope you will understand how I get this equation. Okay, now when do we stop iterating? When the two consecutive iterations will give us the same value of x, y and z, then we should stop. So here what we do is, we can write the above method, that iterative method, in an algorithmic form. So we can write x, y, z as xk, yk and zk, where k will take values from 0 to n. So the kth iteration then, okay, so values of x, y, z in the kth iteration, for that we are going to use xk, yk and zk, and the k plus 1th values can be given using this equation. So if you can see, this is xk plus 1, you have yk and zk here. So when you calculate yk plus 1, you replace now, instead of yk you write yk plus 1, because sorry, xk plus 1, because xk plus 1 was already calculated in the previous step, and here we still have zk because the value of z is still zk, we do not know the new value of z. Similarly, after this calculation we get yk plus 1, so we go to the next calculation now, zk plus 1, using the formula that we know. Now you can see that we have a new value of x here, and I'm not using yk now, I'm using the value yk plus 1 because I had calculated these values in the value in the previous step. So in a similar way you can keep on iterating, and you can find the new values of x, y, z. That is the solution of the system of linear equations. That's all for today. In the next video, we will see how to solve a simple example using Gauss Seidel method. Thank you.